Recognize when they give you this format, you have a curve, parabola, but it's undefined because k over here is not an actual number. This is something that represents what a number would be. Point is, this could be a parabola right now that it's in any position on a curve. Just have that awareness, no problem. And you know there's going to be the same concept over here. You have a straight line, it's going to be an upward sloping straight line, but this straight line could be anywhere on the curve right now. Anywhere on this graph. If you have an XY graph where you were to draw this and to draw this, they could be anywhere right now. Meaning, the relationship between this and this, remember the 3 different ways in which a curve and a line can touch each other. They could be like this, scenario 1, where they don't touch at all. It could be like this, you ring a bell, like the basics over here they're testing you on. It could be touching at 1 point like this, tangent, and it could be like this, you have a curve and they're touching at 2 points over there. Just general awareness, alright? As in, like, you get the context of the question over here, straight line, curve, and they're telling you that if they intersect at these points, by definition is what? Remember, at the end of the day, if you're trying to find k and a, you're just looking for equations that involve k and a. You need 2 equations because you have 2 missing numbers. So without further ado, you'd realize that this over here, they're testing you on, hey, at x equals to 0, they're going to intersect. At x equals to 3 or 4, it's going to intersect. What does that mean? Doesn't that make sense to make these equal to each other first to set up the problem? Or do you need to be told to make those equal to each other? Because you understand, making those equal to each other is setting up that relationship they're talking about over here. When they're talking about intersection relationship, right now, that by itself and this by itself doesn't really mean anything. But when you make them equal to each other, you understand that's how you would set up the problem now, isn't it? Because making them equal to each other, remember math is a language over here, you're setting up the logic. You're saying that they have a relationship with each other, which is making them equal to each other, and then substituting these 2 points in, is how you're going to get relationships. So without further ado, you'd make this equal to this, and you'd understand that x equals to 0 has to make this true, doesn't it? Because that's the equation, that's the relationship that represents this equals to this. That's what represents intersection. Substituting x equal to 0 into here, you can tell what's going to happen over here, because replace the x with 0, see this logic we've articulated over here, when x is equal to 0, comma, this just becomes all 0. 0 minus a. That's the relationship. And rearrange for a is equal to, it just makes sense to get a by itself, right? You get a is equal to this, and we label these. Just good habit to have. When you're doing these questions, always label the simultaneous equations you have. Because it makes it much more clear later on, if you're working under pressure, how to assemble them together. Because you get the general concept of how to solve simultaneous equations. You make one equal to another. Combine them to make the same letter. So we've got the first relationship, a is equal to negative k 0.05 k squared. And then same thing over here, using this information to substitute to make this true. Because you know when x equals to 3/4, this has to equal to this. And that's why you have this and this. And then without further ado, you understand it's going to be a half k squared minus 3 over 4k plus 9 over 4. Moving this to that side, right? You see what we're doing over here? We're rearranging both sides for a, aren't we? Get it? Because this is equal to negative a. So we're moving this to the other side. Why do we rearrange for a? Because if we rearrange for a, right? We can replace the a over here with this. This is just one of many different ways you can solve this simultaneous. My point is, when you make this here like that, and you replace the a over here with this, you're going to get one type of equation. Think about this. Everything over here only involves numbers and k. If you replace the a over here with this, you're going to have only k's now, which creates this equation, isn't it? Remember, there's just one of many different ways you can solve this simultaneous. And then when you combine these, you have a quadratic that these cancel out, don't they? A half k squared, because this is just going to be positive a half k squared, minus each other is just going to cancel out, and this is what you have. And you find k is equal to 2. If k is equal to 2, a is equal to what? Negative 0.5 times k squared, so negative 0.5 times this squared, which is equal to negative 2. And you found the values of k and a, just like that, for 4 marks. Key point over here, make sure you don't panic when it's maybe not entirely obvious what you would do straight away, but you trust that if they're talking about intersection and you haven't made these 2 equal to each other, that's a good starting point, isn't it? The more you write in, the more you fill in, right? The more details you include, the more apparent your solution is going to be.